Hi everyone. So in this video, we're going to continue to talk about the unit circle, specifically focusing on finding terminal points for a whole bunch of different angles. Before we get to the terminal points part, I just want to do a little bit more practice working with radians and kind of being able to locate different angles measured in radians in this kind of new unit circle way of graphing angles. So when we first learned about sketching an angle in standard position, we would just kind of draw it like this. So this is an example of an angle in standard position, something like this. Now that we're going to be using the unit circle and focusing on terminal points, it's really the same idea. It's just that instead of drawing an arrow and kind of letting the angle extend on, we stop it at the place where it hits the unit circle. So all of these different lines that we see, or line segments that we see around the unit circle, each of these represents an angle. So, that would be the first angle, but we're just kind of stopping it when it hits that terminal point. Okay, so I want to go around and label all of the angles that we have shown in this picture, because really these are the most important angles to know. These are all the kind of multiples of pi over 6, pi over 4, and pi over 3. So I would encourage you to pause the video and attempt this part yourself. You might want to watch the first part where I'm going to label the angles in the first quadrant. So I'm going to label like all of these angles. But once you have those angles labeled, you should be able to kind of use them as building blocks to find the other angles. So maybe watch the first few minutes, but then pause the video and try to do the rest yourself. Okay, so let's start with this first angle here. So let me just kind of highlight it. So we're looking at this angle. So this angle, we can see that it is 1/3 of 90 degrees, right? It's like, it would take 3 of them to hit 90 degrees. So we know that it is a 30-degree angle. And remember that 30 degrees is pi over 6. And one way of remembering that's pi over 6 is remember that pi is 180 degrees. So 30 degrees is 1/6 of 180 degrees. And so we can write that as pi over 6. And you can actually see that visually. So here we have 1 pi over 6, 2, 3, 4, 5, 6. So you can literally see that is 1/6 of 180. So that's our first important angle. One thing just I want to mention is that in the past we had been labeling our angles in here. Just in order to keep things from getting too cluttered, I'm going to be labeling the angles outside, kind of next to the terminal point, but I want to make sure you understand that I'm still referring to the angle. I'm not labeling the terminal point, I'm labeling the angle, but I'm just putting that label on the outside of the unit circle to kind of keep things looking tidy. Okay, so our next angle would be this angle here. And so notice that this one is half of 90, and so that means it's 45 degrees. So 45 degrees, if you recall, is pi over 4. So how can we remember that that is pi over 4? Well, pi, again, is 180. So pi over 4 is 1/4 of 180, and 1/4 of 180 is 45. And again, you can really kind of count that out, right? We have 1 pi over 4, 2, 3, 4. So you can really see that pi over 4 is 1/4 of 180. Okay, continuing on, we also have this angle here. And so that is that's basically 2 times pi over 6, right? We can see that pi over 6 was 1/3. This is 2/3 of 90 degrees. And so that's going to be 60 degrees, which in radians is pi over 3. And so again, we can think of that as being 1/3 of 180. And we can really see that here because if you were to divide 180 into 3 pieces, each of them is 60 degrees or pi over 3 radians. Okay, so a couple more angles to put in. I guess we didn't label our starting angle here, so we'll see that there's going to be multiple names that we're going to give to this angle, but one of the names we can call it is just 0, right? This would be like no rotation. The initial point and the terminal, or the initial side and the terminal side are just kind of at the same place. There's no rotation. It's an angle of 0. This angle up here, so that's 90 degrees. It's half of 180, which is pi over 2. Okay, so now the way that we're going to go about filling out the rest of this, the rest of these angles is by basically stacking up these essential angles that we already have labeled. So we can basically do multiples of these angles in order to find the labels of the other angles. So, one angle that we can fill out right away would be 180 degrees, right? We know that that is pi. And one way we could get to that is by saying, well, it's 2 times pi over 2, right? So pi over 2 would put us here. If we stack up another pi over 2, that would be 2 times pi over 2, which would give us pi. Or you can just remember pi is 180. But let's actually do the angle down here. So what is this angle going to be? Well, here is 1 times pi over 2. Let me actually unhighlight this. So that's 1 times pi over 2. This is 2 times pi over 2, which would give you just pi. And so that means that this angle here, this is 3 times pi over 2, which we can write as 3 pi over 2. So that's what I mean by kind of stacking the angles up. 1 times pi over 2, 2 times pi over 2, 3 times pi over 2. And then we can actually keep going. So if we added another pi over 2 in, that would be 4 times pi over 2. But 4 times pi over 2, that would simplify to 2 pi, right? 4 pi over 2 is the same as 2 pi. And so that's what I meant earlier when I said we would give this angle 2 different names. We can either think of it as 0, which would be no rotation, or we can think of it as 2 pi, which would be going all the way around. And those 2 angles, remember, are called coterminal because they aren't the same angle, but they look the same. Okay, so let's now continue to fill in some of these other angles. So maybe let's do pi over 4 next. So here we have 1 times pi over 4. 2 times pi over 4 would give us pi over 2, so that one's already labeled. But then if we add another pi over 4 in, that's going to give us this unlabeled angle. So that's going to be 3 pi over 4. If we keep going, we would get 4 pi over 4, but 4 pi over 4 is already labeled as pi. But if we add another 45-degree angle, that's going to give us 5 pi over 4. So next up, another 45-degree angle, another pi over 4, that would give us 6 pi over 4, but 6 pi over 4 is the same as 3 pi over 2. If you were to reduce it, you would get 3 pi over 2. So far we have 1, 2, 3, 4, 5, 6 pi over 4. That means that this one here is going to be 7 pi over 4. And then the last one here, that would be 8 pi over 4, but 8 pi over 4 is the same as 2 pi. And we've already labeled that. Okay, so maybe let's now do, the multiples of pi over 3. So here we have 1 times pi over 3. If we stack up another 60-degree angle, another pi over 3, that would put us at this angle, and so that's going to be 2 pi over 3. If we add in another 60-degree angle, that's going to give us 3 pi over 3, but 3 pi over 3 is the same as pi. That's already labeled. If we add another one, that's going to put us here. So now we have 1, 2, 3. This is 4 pi over 3. If we add in another one, that gives us 5 pi over 3. So we can label that one. And then if we were to add another one, that would be 6 pi over 3, but 6 pi over 3 is the same as 2 pi. So we're done with those multiples. So we're almost done. Now the only angles that are left to fill out are the remaining multiples of pi over 6. So here we have 1 times pi over 6. 2 times pi over 6 is pi over 3, so that's already labeled. 3 times pi over 6 is the same as pi over 2. 4 times pi over 6 is the same as 2 pi over 3, right? 4 pi over 6 would reduce to 2 pi over 3. So far we have 1, 2, 3, 4 pi over 6. That means that this angle here, which is not labeled yet, that's going to be 5 pi over 6. Here we would have 6 pi over 6, so that's the same as pi. Next up, we would have 7 pi over 6. That is not labeled yet, so we can fill that out. 8 pi over 6 would put us here, but 8 pi over 6 would reduce to 4 pi over 3, so that we already have that one. So let me just count again. So we have 1, 2, 3, 4, 5, 6, 7, 8 pi over 6. This would be 9 pi over 6. 9 pi over 6 is the same as 3 pi over 2. Next, we would have 10 pi over 6, but 10 pi over 6 is the same as 5 pi over 3. now we just have one more. We have 11 pi over 6. And so that one was not labeled yet. And then 12 pi over 6, well, that would be the same as 2 pi. So that's all of the angles that are kind of our most important angles between 0 and 2 pi. I want to be clear, there are other angles, right, that exist. Like, for example, you could say the angle pi over 12. So pi over 12 would be like halfway between 0 and pi over 6. But these are the angles we're going to be working with most commonly, because we'll see that these are the angles whose terminal points are going to be easy to determine. So I don't want you to think that these are like the only angles on the unit circle. These are just the important angles, the angles that we're going to be referring to most commonly. The other thing I want to mention is that I think a lot of people feel like there's a lot of things to memorize in this class, and to some extent that is true. There's definitely some stuff you need to memorize for this class, but I would not say that you need to memorize this whole picture. I think a lot of students feel like, oh, I have to memorize all of these angles. I have to remember exactly how all this fits together. You really don't. What I would say you want to memorize is you want to memorize like these angles: 0, pi over 6, pi over 4, pi over 3, pi over 2. And you don't even really have to memorize them. Really, all it comes down to is the fact that pi is 180 degrees. If you know that pi is 180 degrees, you can easily figure out, oh, pi over 6 is 180 over 6, which is 30, and so on. So if you know these building blocks of pi over 6, pi over 4, pi over 3, pi over 2, you can use those to find any other of these essential angles just by kind of adding them together. So I don't want you to feel like you have to recreate this whole picture every time you're doing something involving these angles. You can just find whichever angle is being asked of you using the process that we just did. So we'll see some examples of that, maybe not in this video, but definitely in our next video. Okay, so I want to do a couple more examples before we get into terminal points of sketching angles on the unit circle. And so these are going to be angles that are not between 0 and 2 pi. And so just want to kind of remind you how you can figure out what those angles look like. So the first angle we have here is 13 pi over 6. So first thing is, how do I know that this is not between 0 and 2 pi? Well, 13 pi over 6, one of the ways that we've thought about an angle like this is like 13 times pi over 6. And so that's one way you can think about it, and that we'll see could be a helpful way to think about it. But another thing you could think of is this is really the same as 13 over 6 times pi, right? These three things are just kind of three different ways of writing the exact same fraction. But the reason that I think this might be a helpful way to think about it is because now you can focus on 13 over 6. So 13 over 6, that is bigger than 2. Right? 12 over 6 would be 2, and so 13 over 6 must be bigger than 2. And so if 13 over 6 is bigger than 2, that means that 13 over 6 times pi is bigger than 2 pi. And so that tells us that this angle is not between 0 and 2 pi. This is going to be one of those angles where you go all the way around in a circle and then you kind of loop back. And so what we need to figure out is basically how much do you need to loop back in order to figure out what this angle looks like. And so for angles like this, the useful thing to think about is you want to think about what is this angle, how much more than 2 pi is this angle? We want to rewrite it as 2 pi plus something. And in some cases, it might be like 4 pi plus something or 6 pi plus something, but 13 over 6 is just a little bit bigger than 2, and so it's just going to be 2 pi plus something. So how much further do we need to go than 2 pi? Well, it's just going to be pi over 6. So how did I figure that out? Well, 2 pi would be 12 pi over 6. So in order to get 13 pi over 6, we just need to go pi over 6 further. So what is this angle going to look like? Well, it's going to go all the way around. That would be 2 pi. And then it's going to go an additional pi over 6. So an additional pi over 6 would put it looking like a pi over 6 angle. And so let me actually redraw the arrow here to make this a little clearer. So this angle is going to be going all the way around like this and then coming back to pi over 6. So just to remind you of some vocabulary that we introduced in a previous video, this angle we would say is coterminal with pi over 6, meaning that even though it's not technically the same angle, it really looks like the same angle. And importantly, it has the same terminal point, right? The terminal point here is the same as the terminal point here because it's on the same part of the unit circle. Okay, so let's do another example. So this one is negative 4 pi over 3. So this one is pretty clear that it's not between 0 and 2 pi, right? Because it's a negative angle. And so for negative angles, really all you need to know is that they're measured in the opposite direction from positive angles. And so we can think of this as, we can kind of just start by thinking of this as 4 pi over 3 and kind of figure that out and then just make sure that we do it in the negative direction. So we can think of this as, and I'll kind of throw the negative sign back in at the end, but let's just forget about it for a second. We can think of this as being 4 times pi over 3. Again, just kind of forgetting about the negative sign. And so that means that it's going to be like doing 4 60-degree angles stacked together. Now we do have a negative sign. And so what that's going to mean is that rather than stacking those angles moving counterclockwise, so like for example here, right, we found 4 pi over 3 by going, okay, 1, 2, 3, 4 pi over 3. But that was moving this way, which is counterclockwise. So in this example, we're going to stack pi over 3s, but we're going to be going instead this way because that's clockwise for a negative angle. And so this is going to be, so here would be negative 1 times pi over 3. Here would be negative 2 times pi over 3. Here would be negative 3 times pi over 3. And so finally we would land here. This would be negative 4 times pi over 3. So our angle, let's see if I can erase this without erasing the circle below it. There we go. So our angle would be like this, measured in this direction. So this is the angle negative 4 pi over 3. So again, we can figure out what angle this is coterminal with because it would have the same terminal point. So if we look back at our original picture, we can see that it is coterminal with 2 pi over 3. And you could also figure that out without looking back up at this picture, because like I said, you don't want to necessarily have to memorize that whole picture. So how could I figure out that this was coterminal with 2 pi over 3 without looking at that picture? Well, I could just measure this way instead. And so if I'm measuring this way, I would have 1 pi over 3, 2 pi over 3. So 2 pi over 3 would be going to that same terminal point, but measuring in the direction of the purple arrow, whereas negative 4 pi over 3 is going to that terminal point, but measuring in the direction of the orange arrow. Okay, so what we're going to do next is work on finding the terminal points of angles like the ones that we have labeled on this unit circle. So we're not going to do all of the angles. And on I think on your worksheet that goes with this video, I actually do ask you to go through and do all of them. We're going to do the ones in the first quadrant, and then we're going to do just a couple of other ones to kind of let you see how it works in the other quadrants. So just to remind you from last time, we learned that the terminal point of an angle is the place where the terminal side of that angle intersects the unit circle. So we did some examples of terminal points last time. So for example, we found last time that the terminal point of the angle pi over 2 is the point 0, 1, right? Because if you go to an angle of pi over 2, so that would be like that, and you look at the coordinates of this point, we can tell that because this is a circle with radius 1, the terminal point of pi over 2 is 0, 1. Or another one that we did is we did the terminal point of pi. So if you go to an angle of pi, that would be over here. Just by looking at the point that we have here, we know that this is the point negative 1, 0. So those are great because you can just find those terminal points just by kind of looking at the picture. But it's not so clear just by looking at the picture. For example, what are the coordinates of this point here of pi over 6? You might be able to estimate. You might say, oh, it's like maybe a little less than 1 for the x coordinate and maybe like a little less than a half or somewhere around a half for the y coordinate. But that would just be an estimate. So what we'll see is that using some of the tools that we introduced earlier in the quarter, we'll be able to actually find exactly what the X and Y coordinates are for all of these special angles that we have labeled on the unit circle. So let me go to this sheet now where we're gonna basically introduce a few facts. I don't know why this is stuck. There we go. Introduce a few facts that will be really essential in the process of finding the terminal points of these different angles. Okay, so first fact. So let's say that we have a point, and this point has some X coordinate and some Y coordinate. So not necessarily a point on the unit circle, just any old point. So if you take this point and you draw a right triangle, and the way I'm going to draw this right triangle is by drawing a line straight down to the x-axis and then just kind of connecting it to the origin. So we have a right triangle that kind of has our point as one of its vertices. So how are the x and the y coordinate of this point related to this right triangle? Well, the x coordinate is the same as the length of this side, right? This side would have a length of x because that's what the x coordinate measures. It measures how far are you going horizontally from the origin. And so from the origin, we're going horizontally a distance of x. And then similarly, the vertical side of that right triangle would tell us the y coordinate because that is how far we're going vertically away from the origin. So let me kind of summarize that. So if you have a point x, y, and specifically in order for what I write down next to be completely true, it needs to be in quadrant 1. And we'll see that really there's a way of kind of getting around this fact, but just to be like correct in what I write down, I have to specify that the point is in quadrant 1. So if you have a point x, y in quadrant 1 and draw a right triangle, I'll just say as shown. So a right triangle, where you're just kind of drawing a line straight down to the x-axis and kind of filling in the triangle. Then x and y are the lengths of the legs of the right triangle. And so basically what this means is that when we get to finding the terminal points of all these different angles, we're going to be able to sketch right triangles and use those to help us figure out what the x and the y coordinate are. So we're going to turn this question of can we find the x and y coordinates, we'll turn it instead into a question of can we find the lengths of a side of a triangle? And that's something we know how to do. And we'll see that we're going to use special right triangles, but I'll get into that in a moment. Okay, the other important thing you need to know, and this is again something that we've talked about, is that you can tell or you can determine whether the x and y coordinates of a point are positive or negative based on what quadrant the point is in. So let me just label these quadrants. We talked about this the other day. This would be called quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And so what I mean by this is, for example, if you have a point, any old point in quadrant 1, not necessarily on the unit circle, just any point, you can tell that the x coordinate and the y coordinate are both positive, just because of where that point is located. Similarly, if you have a point in quadrant 2, well, now you can tell that the x coordinate is negative and the y coordinate is positive. If you have a point in quadrant 3, well, now both the x and y coordinates, those are both negative. I always feel like when I draw that, it looks like a little face with their eyes closed, and these other ones are like winky faces. And then finally, when you're in quadrant 4, in that case, the x coordinate is going to be positive and the y coordinate is negative. So that's not like something you have to memorize, right? It's just something that kind of makes sense. If you just sort of take a step back and think about where are these points located, you can tell whether their x and y coordinates are positive or negative. Okay, last thing, and this is probably like the most important fact we're going to be relying on, is special right triangles. So we learned about special right triangles in our geometry review video. So remember we talked about there's such thing as a 45-45-90 and then a 30-60-90. And we learned that if the side lengths of, maybe let's look at the 30-60-90 first, because I actually have that one first on this current video. If the shortest side has a length of s, the hypotenuse is going to have 2 times s, and then the other side will have s times the square root of 3. And then for a 45-45-90, well, the 2 legs are both going to have the same length, so we can call those both s, and then the hypotenuse will be s times the square root of 3. So if you remember, I've asked you to kind of focus on this one specific example, which is, what are the side lengths if the hypotenuse is 1? So we went through the process of figuring this out, but basically, if you have a special right triangle where the hypotenuse is 1, then the shorter side, let's start with 30-60-90, the shorter side will be 1/2, the longer leg will be square root of 3 over 2, and then the hypotenuse is 1. And then for the 45-45-90, if the hypotenuse is 1, then the other 2 sides are square root of 2 over 2 and square root of 2 over 2. So you can go back to this video if you want to remember exactly where those come from, but they basically just come from the rule that I wrote above here. So let's actually fill that out in these two. So I have these written as like the general rules. I want to fill out the specific one that we just said. So what we just said is that if the hypotenuse has a length of 1, then the shorter side has a length of 1/2, and the longer leg has a length of square root of 3 over 2. And then for this one, if the hypotenuse has a length of 1, then the 2 legs have lengths of square root of 2 over 2 and square root of 2 over 2. And then one other thing that I want to change here is that notice that I have stuff measured in degrees, but we're not using degrees in this video. And for the most part in this class, we're going to be focusing on radians. So I want to relabel these with radians. So instead of saying instead of saying 60 degrees, we know now that that is pi over 3. And then instead of saying 30 degrees, we know now that that is pi over 6. And then for 45 degrees, we know that that is pi over 4. So I'm going to label both of these angles with pi over 4. And by the way, on the topic of memorizing things, of all the things that you might feel like you have to memorize, like this is something that you do want to actually memorize. You want to know the relationships between these specific sides. So when the hypotenuse is 1, what are the other sides? And we will see in just a moment why you do want to have that memorized. Okay, so I have right here pulled up a already labeled unit circle, and all these angles labeled on the unit circle. And what we're going to now do is use the stuff we talked about on the previous page to figure out what the terminal points are for some of these angles. So I want to start with pi over 6. So as we mentioned on the previous page, if we want to find the x and the y coordinate of a point, we can do that by drawing a right triangle. And actually, let me make this a little thinner. If we draw a right triangle like this, if we can figure out what the lengths of the 2 legs are, then this length will tell us the x coordinate, and this length will tell us the y coordinate. So I'm going to take this triangle that we just drew here, and I'm going to make it a little bit bigger because I want to have some space to really label what's going on. So really the triangle looks kind of like this. So what are the angles in this triangle? Well, this angle here we know is pi over 6, right? Because that's the same as the angle we're measuring. And so this angle here is pi over 6. And that means that this angle here has to be pi over 3 because we have a 30-degree angle, a 90-degree angle, we must be left with a 60-degree angle. Okay, so now here comes the key observation. So we know that if you know the length of one side of a special right triangle, you can always find the other sides using the relationships that we know. And so we actually do already know what one of these sides are just based on the fact that this is the unit circle. So maybe pause the video and just think about that for a second. Which of these three sides do we already know without doing any work, just based on the fact that this is the unit circle? Well, we know that the hypotenuse has a length of 1. So how do I know that? Well, the definition of the unit circle is that it is a circle with a radius of 1. And I know that we're kind of thinking about this as being the hypotenuse of a triangle, but it's also the radius of the circle, right? If you think about this this line segment that I'm highlighting here, that's the radius of the circle. And so we know that the hypotenuse is 1. And so using the fact that the hypotenuse is 1, now we can fill in the other sides. This is exactly what we just wrote down on the other page. So the shortest side is going to be 1/2, and the longer leg is going to be square root of 3 over 2. And so now that we know those two side lengths, we can actually figure out what the terminal point is. So the x-coordinate of the terminal point is going to be this distance, right? We said that that is our x-coordinate. And so this distance comes out to be square root of 3 over 2. We just figured that out in this triangle below. And so the x-coordinate of the terminal point is square root of 3 over 2. And then the y-coordinate is going to be the shorter side of our right triangle. And so we figured out that that was 1/2. And so that is our terminal point. And so I'm just going to label that on our drawing as well. So just to be clear, some of these angles are now going to have kind of two things written. One thing is the angle, and then I'm also going to write the terminal point next to it. So we have square root of 3 over 2, 1/2. Okay, so let's do our next angle. So our next angle is going to be pi over 4. So now we're looking at this angle here. And so we basically just do the same process. We draw a right triangle by going straight down like this, because if we draw a right triangle like this, we know that this is going to be our x-coordinate and this is going to be our y-coordinate. And so all we need to do is figure out what are the lengths of those two sides. So I'm going to draw a right triangle based on the one that we have up there. Okay, so what are the angles in this right triangle? Well, this time we're measuring a pi over 4 angle. And so that means that this angle here is going to be pi over 4. And then that means the other angle should also be pi over 4. And so just like in the last example, and this is always going to be the case when we do these, the hypotenuse is going to be 1 because it is the same as the radius of the unit circle. And so if the hypotenuse is 1, well, we learned on the previous page that means that these other two sides have to be square root of 2 over 2. And so now to find the coordinates of the terminal point, well, we know that the x-coordinate is going to be the horizontal side and the y-coordinate is going to be the vertical side. And those both happen to be square root of 2 over 2. So in this case, the x and the y-coordinate of the terminal point are equal to each other. So that is our terminal point, and I'll go ahead and label that up here as well. Okay, so let me take this stuff off. Okay, so next we're going to do pi over 3. So pi over 3, and actually I'm not being super consistent with my color coordination. So let me maybe change that. Okay, so pi over 3, again, we just do the exact same process. So, and maybe at this point, now that we've done a couple, you could pause the video and try it yourself. So we draw a right triangle always by going straight down to the x-axis. That's probably the part that students most get confused about. Sometimes students will try to go this way instead. That actually could work, but for consistency, let's always draw them so that you go straight to the x-axis. And so just like on the previous ones, the shorter side is going to be the x-coordinate, and then the longer side of the right triangle is going to be the y-coordinate. So again, we're going to see for this one, we're going to have a 30, 60, 90 triangle, but the difference is that it's oriented differently. So in this case, now the bottom angle, this angle is pi over 3, right? Because that's the angle that we're really measuring here. So this is pi over 3, and then that means that this angle has to be pi over 6. So again, the hypotenuse is 1 because it's the radius of the circle. And so again, we know that the shortest side is 1/2 and the longer leg is square root of 3 over 2. And so this time, now the x coordinate, again, is the horizontal side. So this time that is the smaller of the two, so it's 1/2. And then the y coordinate is the bigger of the two, so square root of 3 over 2. So we can label that on the triangle here, or on the angle here as well. So this is going to be 1/2 square root of 3 over 2. And one thing that I found that sometimes kind of trips students up, students sometimes get a little bit confused or sort of forget which side is which. You know, they kind of flip the 1/2 and the square root of 3 over 2. And there's a really easy way to figure out which coordinate goes where. 1/2 is a smaller number than the square root of 3 over 2, right? Square root of 3, if you type that into a calculator, I think it's about, don't quote me on this, but I think it's about 1.7. It's definitely bigger than 1. And so square root of 3 over 2 is definitely bigger than 1 over 2. And so basically, if you know that the two sides of these 30, 60, 90 triangles, if you know that one of the sides is 1/2 and the other side is square root of 3 over 2, well, 1/2 is always going to be the shorter distance and square root of 3 over 2 is going to be the longer distance. So for example, for this point here, we can see that the x coordinate is smaller than the y coordinate, right? You have to go less far horizontally than you do have to go vertically to get this point. Whereas for this point, the x coordinate should be bigger than the y coordinate. And so that's why if you compare these two terminal points, they're the same except for that the x and y coordinates are flipped, because it's the same angles, it's just that the sides are oriented differently. Okay, so one more angle within quadrant 1, and then we're going to move on to see how things go a little bit differently in quadrant 2. But this one, we already talked about this in this video. I just wanted to kind of throw this in here to remind you that there are some angles where we actually don't need to draw a triangle at all. So if we go to pi over 2, we can just look at this picture and kind of read what the terminal point is from the picture. So we know that our circle has a radius of 1, and so that means this is a distance of 1. And so the coordinates of this point are just 0, 1. So anytime you're on multiples of pi over 2, you don't need to draw a triangle. You can just look at the picture and use that to figure out what the terminal point is. Okay, so now we're going to get into quadrant 2, and we'll see that this is where things get a little bit different, a little bit, I wouldn't say harder necessarily, but there's just a little bit more to think about. So the next angle we're going to be looking at is 2 pi over 3. So 2 pi over 3 is this angle here. So that would be this angle, right? If we were kind of showing the arrow for it. And the problem is that if we want to use right triangles, we cannot draw a right triangle that actually contains that angle, right? If we tried to draw a triangle that contains that angle, you know, this would be an example of a triangle that contains that angle, but that's not a right triangle, so that's not going to help us. So what we're going to do instead is kind of abandon the original angle, and instead let's just draw a right triangle like this. So again, notice that how did I draw this right triangle? I drew it by just going straight down to the x-axis. You're always drawing your triangle straight down to the x-axis. And you know, you might feel like, okay, but this isn't the right, you know, the angle's out here, like how can we abandon our original angle? And really remember that the right triangles are just here to help us find the x and y coordinate. So as long as we can figure out what kind of a triangle we just drew, it doesn't matter whether our original angle is inside that triangle or not. We just need to use this triangle to figure out the x and y coordinates. So we just want to figure out what kind of a triangle is this and what are its side lengths. Okay, so what kind of a triangle is this? Well, all of the triangles that we're going to be drawing, they're always going to be 30, 60, 90 or 45, 45, 90. Because of the angles we're working with, they just always will be. And so really you can figure out what kind of a triangle it is just by kind of looking at it. So it's not a 45, 45, 90, right? Because the 45, 45, 90s, those happen at the multiples of pi over 4, where the x and y coordinates are the same, where things are kind of balanced, where it's like halfway in between the quadrant. And so this has to be a 30, 60, 90, and you can figure out what the angles are just by looking at what is the smaller and what is the larger angle. So this angle is going to be our pi over 3, and this angle is going to be our pi over 6. Again, you can literally just look at it and kind of figure that out. If you want to know, how could I be absolutely certain that this angle down here is pi over 3? Well, we know that this is 2 pi over 3, right? Because that's the angle that we're actually working with here. And so how much is left over to get back to 180? Well, this additional part here would have to be pi over 3. So let's draw that angle and see what ends up happening. And I always feel like I can't remember how they're oriented when I go back and forth. So let me just go back up here to remind myself. Okay, so it looks like this. So this is our triangle. And as we just described, this angle is pi over 3. This angle is pi over 6. So we know that the hypotenuse is 1, as always. And so that means that the shorter side is 1/2 and the longer leg is square root of 3 over 2. So there's one last kind of piece of the puzzle here. So I'm going to write something down that is actually incorrect. So you might look at this and say, okay, our x coordinate is 1/2, our y coordinate is square root of 3 over 2. But that's actually not correct, because if we go back to our picture, let's think about whether the x and y coordinate should be positive or negative in this example. So forget about the unit circle for a second, just think about this point and where it lies. So because of where this point is located, the x coordinate should be negative, right? It's in quadrant 2, the x coordinate just should be negative. And so what that means is that the x coordinate of this is not positive 1/2, it's negative 1/2. And so why did I not label the triangle with negative 1/2? Well, because when we're labeling the triangle, we're just labeling the lengths of the sides, and you can't have a negative length. So really what we're doing is we're drawing a triangle, we're finding the lengths of the side, but then we have to interpret that in the context of the picture. So if we have a length, looking at our triangle again, if we know that the length of this side is 1/2, but we're moving in the negative direction, that means that the x coordinate should be negative 1/2. So I'm going to label this one with the points we just found. We found that the x coordinate is negative 1/2 and the y coordinate is still positive, right? So it's positive square root of 3 over 2. So it's really the same as what we did in the other ones. It's just adding in that idea of, are the x and y coordinates positive or negative? Okay, so we're going to do another one. This one is a multiple of pi over 4. So I'm going to use blue again. So 7 pi over 4. So where is that? Well, we already have it labeled, but if you didn't have it labeled, you could kind of count to it by just stacking up your pi over 4s, and you would find that it is this angle here. Oops, let me draw that a little better. So 7 pi over 4 is this angle, right? That's the rotation. This time, you can't even imagine drawing a triangle that actually contains that angle, right? That angle is way too big to actually be contained within a triangle. But once again, you don't need to worry about that. The angle that you're actually working with does not need to lie in your triangle. The triangle is just there to help you find the coordinates of the point. So just like we did in all the other examples, we're going to draw a triangle where we take this point and we go straight to the x-axis. So this time, that means we have to go up to get to the x-axis. So every single time, you're always drawing your right triangles so that you go straight to the x-axis, whether that means going up or down. But you never want to be drawing your triangle this way. Again, it could actually work to go that way, but just to be consistent, let's draw them always going straight to the x-axis. Okay, so this time, what kind of a triangle are we working with? Well, anytime you're at an angle that's a multiple of pi over 4, it's always going to be a 45, 45, 90 triangle. Again, you can just kind of see that by looking at the shape here, but if you wanted to be really sure of it, this angle here, remember, that was 7 pi over 4. And so what are you left with here to get back to a full rotation? Well, that has to be a remaining pi over 4. And so our triangle, let me draw it below if I can remember how it looks. So it's like this. So this is a pi over 4 angle, and so this is also a pi over 4 angle. The hypotenuse is still 1, it's always 1. And so then we know that the two sides have to be square root of 2 and square root of 2. And what you might initially say is that, okay, that means that our points are our coordinates are square root of 2 over square root of 2 and square root of 2 over square root of 2. But again, remember, we have to look at which direction we're moving, which quadrant we're in. So if we go back to our picture, we can see that we're in quadrant 4. And so in quadrant 4, the x coordinate should be positive, but the y coordinate should be negative. And so even though the side lengths are both positive, the y coordinate, we're kind of moving a distance of square root of 2 over 2 in the negative direction. And so we want this to be positive. Let me just rewrite it. So the x coordinate is going to be positive square root of 2 over 2. The y coordinate is going to be negative square root of 2 over 2. And maybe let me just add a note. So if you're looking at your notes, you can kind of see where we got those signs from. We know that when you're in quadrant 4, that the x coordinate should be positive and the y coordinate should be negative. And so that's where we got the signs for this one. And then similarly, I'll add that here. So for this one, we were in quadrant 2. So in quadrant 2, we know that the x coordinate should be negative, the y coordinate should be positive. Okay, so I'm just gonna put this label up on the unit circle, and then I think we have one more example, if I'm remembering correctly. I feel like I'm getting writing bigger and bigger as I go. Let me try to be a little more consistent here. So square root of 2 over 2, negative square root of 2 over 2. Okay, two more examples. Okay, so this next one is negative 6 pi. So this is our first angle on this list that is not between 0 and 2 pi, right? It's a negative angle. And so we just need to figure out what angle is this coterminal with, and then we can figure out what it looks like and what its terminal point is. So negative 6 pi, well, that's a multiple of 2 pi, right? It's negative 3 times 2 pi. So what is that angle going to actually look like? Well, it's just going to be going, so 2 pi would be doing a full rotation. We're just going to be doing that rotation 3 times, and we're going to be going clockwise rather than counterclockwise. And so our angle is going to look like this. So we would be going, so negative 2 pi would be like this. Negative 4 pi would be going around again. Negative 6 pi would be going around 3 times. So negative 6 pi would leave us at an angle that is that looks like 0 or 2 pi. So this angle is coterminal with 0, or you could say it's coterminal with 2 pi. It doesn't really matter. So I'll write that down. This is coterminal with 0, or you could say it's coterminal with 2 pi, either one. And so just by looking at the picture, we can tell that the coordinates of its terminal point are 1 and 0. We don't need to draw a triangle. We don't have to do any extra work. We can just kind of look at the picture. Okay, last example. So this is going to be another one that is not between 0 and 2 pi. So we have 13 pi over 4. So we need to kind of make sense of this angle. So 13 pi over 4, I recommend kind of doing what we did before and thinking about that as 13 over 4 times pi, and looking at this number to figure out, is this number bigger or smaller than 2 pi? So 13 over 4 is definitely bigger than 2, right? 8 over 4 would be 2, and so 13 over 4 is bigger than 2. And so that tells us that this angle is bigger than 2 pi. And so we want to figure out how much bigger than 2 pi is it. So, we want to rewrite it as 2 pi plus something. And so to figure that out, it might be helpful to make a common denominator for what we're going to be looking for here. We're working with a denominator of 4. So let's rewrite 2 pi as 8 pi over 4. So we have 8 pi over 4 plus, what is left over? What would we need to get 13 pi over 4? Well, we would need an additional 5 pi over 4. So it's equal to 2 pi plus 5 pi over 4. And so that tells us that this angle is going to be coterminal with 5 pi over 4. What is this angle going to look like? Well, it's going to be going all the way around. That would be 2 pi. So that would be 2 pi. But then we're going to keep going to an angle of 5 pi over 4. So we did 2 pi plus 5 pi over 4. And so now we can look at this, we can basically just look at 5 pi over 4 and figure out what the terminal point is for that, because it's the same. as the terminal point for the angle we're working with. So how do we find the terminal point for 5 pi over 4? Well, we do what we've been doing all along. We draw a triangle by going straight, in this case, up to the x-axis, so always going to the x-axis, and that's what our right triangle would look like. And so in this triangle, it's a multiple of pi over 4, so we basically know that this angle and this angle are both pi over 4. So let me draw that triangle, and I think I have trouble visualizing some of these things in my head, so I always have to focus before I go and copy it down here. So I think it looked like this. So we said this is pi over 4 and this is pi over 4. And so when you have pi over 4 and pi over 4 with the hypotenuse of 1, we know that we have square root of 2 over 2 and square root of 2 over 2. And then we also know that in this case, we're in quadrant 3, right? And so the x and the y coordinate are both going to be negative. And so the x and y coordinates in this case are going to be negative square root of 2 over 2 and negative square root of 2 over 2, because we're moving a distance of square root of 2 over 2 in both directions, but it's negative because we're in quadrant 3. Both directions are negative. So in quadrant 3, both the x and y coordinate are negative. So I'll label that up here. So we had negative square root of 2 over 2, negative square root of 2 over 2. Okay, so that is the last example for this video. There's one more thing I just want to mention that I think is pretty important. So a lot of people, and this is kind of related to something that I said earlier in the video, a lot of people feel like I'm asking you to memorize all of these terminal points, that you need to find all the terminal points on this and memorize them, memorize all the angles, memorize all the terminal points. You do not need to do that. You do not need to memorize all of the terminal points. What you do need to know is the process for finding the terminal points. And the process for finding the terminal points, the only thing that really needs to be memorized for that is the special right triangles. If you know your special right triangles and you know kind of how to tell whether a point has positive or negative x and y coordinates, that's it. That's really all. And you might notice some patterns, right? Like any angle that is a multiple of pi over 6 or pi over 3, the coordinates are always going to be a half and negative root 3 over 2. So it's really just a matter of figuring out which side is which, which way is that right triangle oriented. And once you work with these more, you might get to the point where you don't actually have to draw a triangle every time. You might be able to just kind of visualize what kind of a triangle you're working with. But for now, I really recommend drawing these triangles, getting that practice in, and don't get overwhelmed. Don't feel like you have to memorize all of this. Just focus on the process, and that way you can find the terminal points for any angle regardless of what you have memorized or not. All right, so that is it for this video. In our next video, we'll finally see why we're talking about terminal points. So we'll see that all the stuff we worked on today is basically getting us ready to do trigonometry, and kind of jump straight into that because we have a lot of practice now with finding terminal points. So I'll see you all in our next video.